and the good. I have to celebrate you, baby. I have to praise you like I should.
Okay, 2.4 is on permutations with repetitions. So I said we'd do this a couple days ago. I made a mistake, and now we're going to actually do it. So let's start by looking at these three situations. We have the letters T-O-P, top, and we're going to rearrange these letters in as many different ways, as many permutations as possible. So how many ways could you rearrange those letters? Let's actually list them here. So we could have T-O-P, or we could do T, but then P-O. Okay, that's with the T first. Let's put the O first now. You could have O-T-P or O-P-T, and now let's put the P first. You could have P-O-T or P-T-O. That's all of them. Count them up. 1, 2, 3, 4, 5, 6. 6, and that shouldn't be too surprising because what you know is that when you're taking n distinct objects, these are all distinct, and you're choosing n of them, so you're rearranging all three of them in this case, then the number of permutations is 3 factorial, or it would be n factorial, in this case 3, and 3 factorial equals 3 times 2 times 1 equals 6. So we did that already, right? N factorial is what you'd expect it to be. N is equal to 3, 3 factorial 6. Okay, now we're going to do the same sort of thing, but this time we're going to, you see we have some repetition here. We have 2 t's in here. So we're going to do the same thing. We're going to write all the different permutations. And this could get confusing because we have the same t. We have t twice. They're identical, aren't they? So just to distinguish them, I'm going to make this one t prime. First of all, we have t o t prime. Then we have t t prime o. Then we'll put the o first. O t t prime and o t prime t, and then we'll put the t prime first. T prime t o and t prime o t. Now, if you remember, you actually have these t primes and t's are actually the same. So where we have t o t prime, it's just t o t, and this is also t o t at the bottom here, isn't it? So this is exactly the same as the top one. We don't want to count it twice. I'll get rid of this. T t o. Well, here's another t t o. Same thing. O t t. Here's another o t t. Gone. So you're actually only left with 3 of them. Now, why is that? Why are you only left with 3? Well, again, you started off with 3 factorial things, which is equal to 6, but instead of ending up with 6, you actually ended up with 2. So what did you have to do to the 3 factorial? You had to divide it in 2, right? Half of these permutations are actually gone. So you divide it by 2, and you end up with 3. Now, you're going to see in a second here, you didn't actually divide by 2, you divided by something slightly different. You'll see in a second. But hopefully this makes sense for now. You had 6 permutations, we divide it by 2 to get 3. Okay, now we're going to do the same sort of thing, but we're going to work with 3 objects that are exactly the same. Again, let's call the first one t, the second one t prime, this third one t double prime, just so we can distinguish them when we make our list. So we have t, t prime, t double prime, or we have t, t double prime, that's a double prime, and t prime. Let's put t prime first now. T prime, and then t double prime, t prime, and then t double prime, and then t, and now I put the t double prime first. I hope you agree with me. This is actually just a kind of a foolish waste of time, because if you really think about it, even though we have 6 cases here, they're all identical to each other, aren't they? We said at the start t and t prime and t double prime are actually exactly the same thing, so really what you're left with is just one thing. I mean, you could cross out all of these because they're all just the same as this first one here. So again, what you have is you started with 3 factorial to get these 6, but then you actually divided by 6 this time. Now, what's this bottom number? Like here it was 2, and then suddenly here it's 6. Can you figure out where that comes from? It's because this actually isn't 2. This is 2 factorial. But remember, 2 factorial is 2 times 1, which is just the same as 2. But here, because all 3 things are identical, we're dividing by 3 factorial. Hey, that's exactly the same as each other. 3 factorial is 6, 3 factorial is 6, 6 divided by 6 is 1. And that's exactly right. There's only one thing you can get if you start with t, t, and t. So, if that confuses you, here's the formula. The number of permutations of n objects That's how many you started with, all right? If A objects are alike, and another B objects are alike, and another C objects are alike. So for example, in this question right here, this TOT, ignore the T prime, we're no longer interested in that. This would be like the number of permutations of N objects, well in this case it would be 3. If A objects are alike, well that'd be 2 objects are alike. And another B objects are alike, well you just have one O. So it'd be if 2 objects are alike and then 1 object. The way you get it is you do the following equation. You do n factorial, right? There was, in each case, there was 3 things we started with, and we put 3 factorial, 3 factorial, 3 factorial. So n factorial, but then you divide by a factorial times b factorial times c factorial, dot, 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 because there could be d and e and e and f and all that kind of stuff, where a plus b plus c plus dot dot dot, because there could be a d and e and f, equals n. That's the formula. Okay, let's look at these examples, and I think this will help you understand. So the first one says, how many different signals can be made from 6 flags hung in a vertical line? So you're going to hang up some, you got this pole or something, and you're going to hang a bunch of flags up there, and the order that you put the flags on gives you a signal. Right? So if it's red, 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 it means help, and if it's red, white, red, it means bring ice cream or something. I don't know. That's ridiculous, isn't it? How many different signals can be made from 6 flags hung in a vertical line if all the flags are different colors? So you already know this question. Like if they're all different, then the formula is just n factorial, isn't it? But you can also think of it as being this way, n factorial over a factorial, because that would be like 6 factorial. But since they're all different, how many is there of the one type, like whatever the first color is? Let's say the first type's red. There's only 1, so it'd be 1 factorial. How many in the second type? Only 1 factorial. The third type, 1 factorial. The fourth type, 1 factorial. The fifth type, 1 factorial. And the sixth type, 1 factorial. Now it's kind of silly to write that, but I just want to show you that this equation works even for the ones where there is no repetition. 6 factorial over 1 factorial, 1 factorial. What's 1 factorial equal? 1. So on this bottom part, you have 1 times 1 times 1 times 1 times 1 times 1, which is just 1. You're left with 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and that equals 720. Okay, if that confuses you, just ignore this bit, and just remember that if all the things are different, you just do n factorial. And n factorial, in this case, would be 6 factorial. Okay, the next one. So this time we have 6 flags, but 2 are white, 2 are red, and 2 are blue. The white ones are identical to each other. The red ones are identical to each other. The blue ones are identical to each other. So what we do is, again, n factorial. So how many flags total? 6. So that's 6 factorial. But then 2 of the white ones, they're identical. So we have 2 white ones are identical, 2 factorial. Then we have 2 red ones that are identical, so 2 factorial. Then we have 2 blue ones that are factorial, 2 factorial. And do you see that this 2 plus 2 plus 2 equals 6, just like we said it would right here. And now we can actually get the answer. Okay, so 6 factorial is 720, and then 2 factorial is 2 times another 2 times another 2, so you end up with over 8, and 720 divided by 8 is 90. 90 different ways you could arrange the flags if 2 are white, 2 are red, and 2 are blue. Next one. This time we have 6 flags again. 3 flags are white, 1 is red, and the others are blue. Well, how many blue ones are there? There's 6 total, 4 here, so that means there's 2 blue ones. Okay, same thing. We start with 6 flags, so 6 factorial. But some are identical, aren't they? 3 of the white ones are all identical, so we put 3 factorial. 2 of the blue ones are identical, so we put 2 factorial. And you can just stop there if you want. Alright, that's fine. But in order, just so it makes sense to you here, remember we said that a plus b plus c plus, they have to equal up to n? Right now it doesn't. We just have 3 plus 2 is 6. But remember, we also have this 1 red one, so if you wanted to, you could also put 1 factorial. But do you get why that's not necessary? Because 1 factorial is just 1. You really only have to include the things that are repeated. The 3 white flags, you have to put a 3 factorial because that's identical flags which are repeated. The 2 blue ones, you have to put a 2 factorial because those are repeated ones that are identical. But you don't need to put the 1 factorial if you don't want to. Alright, 6 factorial we already said was 720. 3 factorial, that's 3 times 2 times 1 is 6, and 2 factorial is 2, so you get 720 over 12. 12 goes into 72, 6 times 60. Our answer is 60. How many ways can the letters of the word Canada be arranged? So we're going to rearrange all these letters. How many are there? 1, 2, 3, 4, 5, 6. So the answer again is just like here, 6 factorial. Great. And if all these letters were different than each other, that's all it would be is 6 factorial. But they're not all the same. Which ones are repeated? A, A, A. Those are all repeated. So because they're repeated, you have to decrease this amount, right? There's not going to be as many because there's some repeated identical elements here. And since there's 3 of them, it's going to be divided by 3 factorial. You can just do that, 6 factorial divided by 3 factorial. Or if you want, you can say, I have 1c, I have 1n, I have 1d, so 1 factorial, 1 factorial, 1 factorial. But again, it's kind of a waste of time because 1 factorial is just 1. 6 factorial, I'm getting sick of this. 6 factorial is 720. 3 factorial, that's 3 times 2 times 1 is 6. And 720 divided by 6 is 120. How many ways can the letters of the word Canada be arranged? So exactly the same as one we just did, but this time the first letter must be N and the last letter must be C. Alright, so 6 letters, 1, 2, 3, 4, 5, 6. First letter must be N, last letter must be C. Okay, so all you really have to do is take a look at what's left. Well, we used the C already, this last one, and we used the N already, so that's gone. So you're now left with 4 letters that you're going to get the permutations of that. So the formula is 4 factorial. Any repeats? Absolutely. There's 1, 2, 3 A's. So you got to divide it by 3 factorial. You also have a D, so if you wanted to, you could put 1 factorial. You don't need to. 1 factorial is just equal to 1. 4 factorial, that's 4 times 3 times 2, which is 24. And 3 factorial is 3 times 2 times 1, which is 6. 24 divided by 6 is 4. Wow, there's only 4 ways you could arrange those letters. And that makes sense, because one way is to have the D first, and then AAA. One way is to have the D second, and then AAA. One way is to have the D third, and then AAA. And one way is to have the D last, and then AAA. And there's no other way to do it, because all the A's are identical. Okay, now we're going to do something completely different. We're going to start at A here, and we're going to go to B, and the rules are there's 2 rules. The first rule is you have to stay on the streets here. Okay, you can't cut across places like this, or you can't do that. You have to stay on the streets. The other rule is you always need to move towards B. You can't move away from it. In other words, you can only move right and down. You can go down and you can go right again, but you can't go back up. It's not allowed. You go right, down. You can't go left because that's also going away from B. You can only go right or down, and we want to know how many ways are there to go from A to B. Wow, there's a lot of them. I mean, one way is just to go straight across and then straight down. There's one. Another way is to go all the way down and then across. There's 2. But there's so many other ways, right? I could do something like this, like that, or I could go over to here and then down to here and then down there. I do not want to count them all. There's way too many. So there must be a better, faster way of doing this. There's actually 2 ways you can do this, and we need to learn them both. One way, believe it or not, is to think of permutations. So in order to get from A to B, no matter which way you go, how many steps are you going to have to take? For example, if I just do this simple way here, how many steps do I take? I go 1. How many blocks, I guess we could think of it? 1 block, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. We went 8 across and 4 down for a total of 12. Okay, do any other pathway. I don't know, I'll just draw this one. Doesn't matter which one you draw. Okay, how many times did you go across? 1, 2, 3, 4, 5, 6, 7, 8. You went 8 across. How many times did you go down? 1, 2, 3, 4. It's always going to be the same. It's always going to be 8 across, 4 down, no matter which way you do it. So if you think of it, what you're really doing is you're making 12 moves total, where 8 of them are identical to the right, and 4 of them are identical down. Do you see what you can use? You can use the formula we've been using on the other side of the page. What you need to do is 12 factorial divided by how many moves are there to the right which are identical? 8, so 8 factorial. How many moves downwards which are repeated? 4, so 4 factorial. Oh gosh, well let's see, it'd be 12 times 11 times 10 times 9 times 8 factorial, which would cross out this factorial. And the bottom we'd have 4 times 3 times 2 times 1, which I don't even need to put. and then I could do some simplifying here. 4 times 3 is 12, so that crosses this out, and I could divide the 10 by 2 to get 5. So what I'm left with is 9 times 5 is 45, times 11 is 495. That's how many different ways there are to go from A to B if you're only moving down and to the right. Thank goodness we didn't try counting them all one after the other. That'd be a nightmare. Now there is another way to figure out how many ways there are to go from A to B, and it's actually kind of cool. If you started at A here, how many ways are there to get to this intersection right here? There's only one. You can't go like this, right? The only way you can get to here is straight down. 1. How many ways to get to here? Also just 1. How many ways to get to this spot here? There's still only 1. Do you see that? You can't, because any other way to get there would involve either going up or going left, and you can't do that. So only one way to get here. Only one way to get here. How many ways to get to here? Only 1. In fact, all the way across here, there's only one way to get to any of these intersections just by moving across there. Same with going down here. The only way to get to here is one way. There's only one path to get to here. Right? There's no other way to get to that intersection. It would involve moving left or moving up, and you can't do that. So one pathway, one pathway, one pathway, one pathway. Now, here's the key to this. Can you figure out how many ways there are to get to here? Well, it's not that hard. To get to here, there's 2 ways. You could go this way, or you could go this way. So I'm going to put a 2 here. And you might notice something. We'll try one more. It's going to be a little more difficult, but let's see if we can figure out how many ways to get to here. Well, you could go across and down, so that's 1. You could go down and across, so that's another 1. Or you could go across, down, across, so that's another 1. So 3. Alright, anyone see what's going on here? If this is 1 to here, and this is 1 to here, and this is 2, and this is 2 to here, and this is 1 to here, and this is 3, what can we do every time? You can add 1 and 1, 2, 2 and 1, 3. Guess how many ways there are to get from to here? Well, you could come from here, which there's 3, or come from here where there's 1, so 4. How about to get to here? You could come from here where there's 4, there is 1, 5, 6, 6 and 1, 7, 7 and 1, 8, 8 and 1, 9. How about here? You could come from here or here, 1 and 2, 3. How about to get to here? 3 and 3, 6, 6 and 4, 10, 10 and 5, 15, 15 and 6, 21, 28, 28 and 8, 36, 45. I should have made this smaller, this is ridiculous. 1 and 3 is 4, 4 and 6 is 10, 10 and 10 is 20, 20 and 15 is 35, 35 and 21 is 56, 56 and 28 is 84, 84 and 36 is 120, and 120 and 45 is 165. So there's 1 way to get to here, there's 4 ways to get to there. How many ways to get to here? 5. 5 ways to get to here, 10 to here, so 15. 35, 70, 126, 210, 210 and 120 is 330, and if there's 330 ways to get here and 165 ways to get here, I add them together and I get 495, and thank goodness we get exactly the same answer. Okay, the next one, here's our A, here's our B. Unfortunately, you can't use the permutations formula in this one. The reason is because you have these big gaps where, and it has to be completely symmetric, or, you'd have to have this, and you'd need this, and then you could actually use the permutations formula, but you can't in this case because you have these extra big blocks in here, big empty lots or something. So you can only use the method we just used, which was to look at each of the pathways. How many ways are there to get to this? 1. How many ways to get here? 1. How many ways to get here? 1. And even all the way over here, there's only 1 way to get there. The only other way to get there would be to come up. You can't go up. Same with down the side. It's always going to be like this. The sides, it's always going to be 1, 1. How many ways to get here? 2. How many ways to get here? 3. How many ways to get here? 4. How many ways to get here? 5. How many ways to get here? 6. How many ways to get here? 7. How many ways to get here? Well, 2 here, 1 there, 3. How many ways to get here? 3, 1, 4. How many? What? It just kind of stops there. This is a little strange, isn't it? Okay, how many ways are there to get to here? Well, the only way you can get to this spot here is to come from this 3. You can't come from the 4 because you'd be going left or you'd be going up. So you have to come from the 3. If there's 3 ways to get here, and the only way you can get to this one is also from that one, then there's also only 3 ways to get here. You see why you're not adding anything to that? The only way you can get to this one is from here. But on the other hand, in order to get to this point, you could come from the 4 or you could come to the 3. That's why you add them together and get 7. How many ways to get here? There's only 1 way to get here from the 7, so it's still 7. How many ways to get here? You could come from the 7 or the 1, so it's 8. How many ways to get here? There's only one way to come from the 3. How many ways to get here? 3 and 7, 10. There's 2 ways to get here. 10 and 7, 17, 17 and 8, 25. How many ways to get here? 2 from the 5 or the 3, so 8. 8 and 10 is 18, 18 and 17 is 35, and 35 and 25 is 60. Okay, to get from to here, you come from the 6 or the 8, 14. To get from here to here, 7 and 14 is 21. How are you going to get here? The only way you can get there is from the 14, so it's going to stay 14. How about here? The only way you're going to get there is from the 14. The only way you're going to, actually there's 2 ways to get here, from the 14 or the 60, so 74. To get here, 21 and 14 is 35, 35 and 14 is 49, and 49 and 74 equals 123 pathways from A to B. Okay, the last one. Believe it or not, we can do both methods. Let's start with the method we've just been using. We'll go fast this time. We're going from A to C. We have to go through B. So 1, 1, 1, 1, 1, 1. 1 and 1, 2, 2 and 1, 3, 3 and 1, 4, 4 and 1, 5. 1 and 2, 3, 3 and 3, 6, 6 and 4, 10, 10 and 5, 15. So to get to this dot, there's 15 ways to get there. How many ways to get to here? Well, you have to come from that dot. That's the only way you can get there. So still 15, still 15, still 15. And same with this dot. To get to this intersection, you have to come from the big dot. So it's 15, 15, 15. Then we do the same sort of thing. 15, 15, 30, 30 and 15 is 45, 45 and 15 is 60, 15 and 30 is 45, 45 and 45 is 90, 90 and 60 is 150, 15 and 45 is 60, 60 and 90 is 150, 150 and 150 is 300 ways to get from A to C through B. Now, we can actually do this the other way too with permutations and combinations. For example, to get from A to B, let's just look from A to B. No matter which way you go, how many steps is it always going to be? It's going to be 1, 2, 3, 4, 5, 6. Always going to be 6 steps, so 6 factorial. But how many of those steps are identical? Well, you have 4 steps to the right. No matter which way you go, there's always 4 steps to the right. 1, 2, 3, 4. And there's always 2 steps down. So 6 factorial over 4 factorial times 2 factorial. Now let's look at this bit down here. How many ways are there to get from B to C? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Always 6 factorial again. How many steps are there to the right? 1, 2, 3. 1, 2, 3. Always 3 to the right. How many down? 1, 2, 3, or 1, 2, 3, always 3 down. So this is how we're going to get the number of permutations in here. Now, is this an or question or an and? Are you going to do these movements and these movements, or do you either go from A to B or from B to C? You're doing both. This is an and question. So once you get this answer, you have to multiply by this answer. Okay, this one. I think we said 6 factorial was 720. 4 factorial is 24 and 2 factorial is 2 times 720. 3 factorial is 6 times 6. So this is 720 over 48 times 720 over 36. 48 goes into 720 15 times, and 36 goes into 720 20 times, and 15 times 20 is 300, and that's exactly the answer we wanted. It worked. Okay, I kind of enjoy those permutations, pathways questions, and I hope you do too. So that's it for permutations. Next day we'll start combinations.
I have to praise you like I should.